Okay, good afternoon, students. Myself, Mastan Rauchundi from Computer Science and Engineering Department, Chevrolet Engineering College. Okay, in last class we have discussed about guided transmission medium. In that guided transmission medium, we have discussed about several guided transmission mediums. Those are magnetic tapes, optical fibers, twisted pair cables, electrical cables, etc. Okay, now coming to the today's topic. Uh, Today we are going to discuss about unguided transmission medium. Okay, hope you all know about unguided transmission medium. In this unguided transmission medium, most of you people know about microwave, light wave, and radio waves. Okay, now coming to the unguided transmission medium, it is different from guided transmission medium. In guided transmission medium, we need a physical path. If we need a physical path to guide the waves. We need a physical path to guide the waves. Whereas in unguided transmission medium, we don't need any physical path. We don't need any physical path. Okay, that is the difference between guided and unguided transmission medium. Here, we don't need any physical path to guide the waves. Okay, this is the difference between guided and unguided. Now, coming to the types of unguided transmission medium, we have majorly 4 types of unguided transmission mediums. Those are which you are viewing on the screen. The first one is radio transmission, microwave transmission, infrared transmission, and light wave transmissions. These are the most important unguided transmission mediums that we have. Okay, coming to the first category, first type, that is the radio transmission. In radio transmission, and these are the most widely used communication nowadays, because these waves are easy to generate. These radio waves are easy to generate and travel long distances and it can penetrate to the buildings, it can penetrate to solid objects, and etc. Okay, the main advantage is it is easy to generate and travel long distances. This is the major advantage of radio transmission. Okay, and one more important point with respect to radio transmission is these radio waves are omnidirectional. Okay, I think all you know about these directions: unidirectional, bidirectional, simplex, duplex, half duplex. Okay, these radio waves are omnidirectional. OMNI, omnidirectional. Omnidirectional is nothing but the waves can travel in all directions from the source. Okay, from the source, these waves can travel in all directions. This type of procedure is called as omnidirectional. Okay, and here this radio transmission does not require any transmitter and any receiver physically. Yesterday we discussed about to receive the light waves we need a decode. We need a physical device at the receiver's end. Like that, here there is no setup of transmitter. Transmitter is nothing but sender. No need to align the sender and receiver physically. This is the one more advantage of radio transmission. Okay, and that these radio waves are frequency dependent. This is the most important point you need to note down. These radio transmission waves are frequency dependent. Even at lower frequencies, they can travel. Okay, even at lower frequencies they can pass. Okay, and yet at higher frequencies the waves travel in a straight line. At lower frequencies it can even at lower frequencies it can travel. When comes to the higher frequencies, these waves can travel as straight line. These waves can travel as straight line. The major application that we are using radio transmission is all our digital communication is happening through this radio communication, mobile signals and everything, and television, mobile signals, all these are comes under category of radio transmission. This is the first kind of unguided transmission medium, that is radio transmission medium. Now coming to the second kind, that is second type of unguided transmission medium, that is microwave transmission. I think hope all you might known about this microwave. Already you might have completed microwave engineering, etc. This is the another microwave transmission is the another unguided transmission medium. Here in this type of transmission, the energy is concentrated into a small beam, that is light type this is a light type transmission. All the energy is concentrated into a small beam, and this beam is transmitted. Here here that this is different from radio transmission. In this microwave transmission, we need to have a setup at receiver and sender. Okay, we need to have a receiving antenna. We need to have antennas at the receiver. Okay, to receive that light. Whereas in radio transmission, we don't need any setup to receive the transmission. In microwave, we need a receiver to receive the light. Okay, and at lower frequency, this is not frequency dependent, whereas the radio transmission is the frequency dependent. The micro transmission at lower frequencies, the microwaves do not pass through the buildings. It needs higher frequency to pass the buildings. It cannot penetrate through the solid objects. Okay, this is the information about microwave transmission. Okay, microwave is nothing but a concentrated the energy, all the energy is concentrated into a small beam. This is called as microwave transmission. Okay, the waves travel straight lines above 100 megahertz. These waves can travel 100 megahertz. Okay, this is about microwave transmission. Just moving to the next one. All you know about this infrared transmission. The best example for infrared transmission is our remote control and our VCR, VCD. Okay, coming to the infrared waves. These infrared waves, this can also called as millimeter waves. These infrared waves are also called as millimeter waves. Here, the waves are. This is very cheap and easy to build. This type of transmission is very cheap to install and very easy to build. And one more point about this infrared is this is limited to small distance. This infrared transmission is limited to small distances, like our TV remote. It cannot the TV remote transmission cannot pass through solid objects. It cannot pass through solid objects. It can limited to one room. Maximum it is limited to one building. Okay. This is about the third kind of unguided transmission medium, that is infrared transmission. Last one in unguided is light wave transmission. Here, this type of light wave transmission is used to connect the lands. Suppose, let us take an example. Our college is having two buildings, two different buildings. These two are two separated buildings, and these two are having separate lands. Building A is having one land, building B is having another land. without physical connection, these two LAN without physical connection, these two LANs are connected in a fashion where at the roof of the building, at each roof of the building, we need to arrange a light, we need to arrange a laser light. Okay, by using these laser light, two LANs are connected. Here, the type of signaling is called optical signal by using lasers. The optical signal by using lasers. This is not multi-directional. At a time, both two sides transmission is not possible by using this light wave transmission. This is having only light wave transmission in unidirectional. At a time, building A can transmit the data to building B, and building B is transmit to data to building B, but it not happens simultaneously. Okay, this type of transmission is called as light wave transmission. These are the types of guided unguided transmission medium. The first one is radio transmission. This is very useful in nowadays. Better applications for this radio transmission is television and radio signals. Next, microwave transmission. In this microwave transmission, we need a separate setup at sender and receiver to receive the beam of light. And infrared transmission, this is limited to one building, or this is limited to one room. And last one, that is light wave transmission. This light wave transmission is used to connect the LANs between two or more buildings. This is a unidirectional data transmission. Okay, this is all about unguided transmission medium. And both guided and unguided transmission medium is very important with respect to examination point of view. Okay, once this unit is completed, I will share you the material along with the PowerPoint presentation what I have completed. Now moving to the next topic, very interesting one and easy one. The next topic is multiplexing. The next topic is multiplexing. Most of you people know about multiplexing. First, this topic already you covered in multiplexing, you covered in computer architecture, etc. Here, coming to the definition of multiplexing, in computer networks or any point with respect to telecommunications, the multiple, listen the definition, the multiple analog or digital signals, the multiple analog or digital signals are combined to form a single signal. Multiple analog or digital signals are combined to form a single signal, and this single signal is passed or shared through a shared medium. This is the important point. This combined signal is passed over a shared medium. This is called as multiplexing. This is called as multiplexing. In multiplexing, according to our syllabus, we have 4 types of multiplexing techniques. Those are frequency division multiplexing, wavelength division multiplexing. Frequency division multiplexing is called as FDM, and wavelength division multiplexing is called as WDM, and time division multiplexing is called as TDM, whereas code division multiplexing is called as CDM. Code division multiplexing is called as CDM. In this multiplexing techniques, the time division multiplexing and frequency division multiplexing is the most used multiplexing techniques, whereas the code division multiplexing is used for mobile communications, used for mobile communications. Okay, I will tell you how it will be used in mobile communication later. Now moving to the next slide, that is we are going to discuss about frequency division multiplexing. Very simple topic. This coming to general point of view, this frequency division multiplexing is used in our FM radio, our frequency modulation radio. All we are listening daily FM radio. In this application we are using this type of multiplexing, where a set of radio stations can transmit electromagnetic signals simultaneously. Like our radio station, what radio station will do? It will transmit the electromagnetic signals simultaneously. Okay, అంతే కదమ్మా. మనకి ఇక్కడ రేడియో స్టేషన్ ఏం చేస్తుంది? 98.3, 93.5, some etc. XYZ. All these electromagnetic signals are transmit simultaneously. ఎలా simultaneous గా పాస్ చేసినా కానీ ఒక స్టేషన్ ఇంకొక స్టేషన్ దాంతో ఇంటర్ఫియర్ అవ్వకూడదు. That means it cannot interfere with another signal. One electromagnetic signal ఇంకొక ఎలక్ట్రోమాగ్నెటిక్ సిగ్నల్ లోకి ఇంటర్ఫియర్ అవ్వకూడదు. అంటే వచ్చేటప్పుడు అన్నీ కూడా మల్టీప్లెక్స్ అయ్యి వస్తాయి, సింగిల్ సిగ్నల్ గానే వస్తుంది. కానీ రిసీవర్ దగ్గరకు వచ్చేటప్పటికి, సపోజ్ యు ఆర్ లిజనింగ్ 98.3, ఐఎమ్ లిజనింగ్ 93.5, బట్ ఏం రావాలి? నా దగ్గరకు వచ్చేటప్పటికి ఓన్లీ 93.5 రావాలి, మీ దగ్గరకు వచ్చేటప్పటికి 98.3 రావాలి. వాళ్ళ దగ్గర నుంచి ఎలా వస్తుంది? సింగిల్ సిగ్నల్ గా వస్తుంది. ఆల్ ఎలక్ట్రోమాగ్నెటిక్ సిగ్నల్స్ ఆర్ కంబైన్డ్, మల్టీప్లెక్స్ అయి వస్తున్నాయి. ఆల్ ఏబిసి అనేవి మూడు కంబైన్ అయి సింగిల్ సిగ్నల్ లాగా వస్తుంది. నేను ఏ చూస్తున్నాను అనుకో, నా దగ్గర సపరేట్ అవ్వాలి, డి మల్టీప్లెక్స్ అవ్వాలి, మీ దగ్గర బి రావాలి, ఇంకొకరి దగ్గర సి రావాలి. లైక్ వైజ్ హియర్ we don't have any interference. Okay, see how the example. This is how the frequency division multiplexing. This diagram shows the first left side one, the frequency for all channels. This is the frequency for all channels. This is the demultiplexer. This signal is after multiplexing. This is, see my cursor, this is after multiplexing, and this multiplexed signal is passed through the demultiplexer. This multiplexed signal passed through demultiplexer. Here after filtering this one, we can separate the signals here. The separated signals are passed here. Okay, this is the frequency division multiplexing. See the next diagram. Here you can understand clearly. Here see the sender one here, sender 1, sender 2, n senders are here. All these three signals, sender 1, sender 2, sender 3, all three signals are passed through the multiplexer. What is the responsibility of multiplexer? The multiplexer will combine all the signals. The multiplexer will combine all the signals and to form a one signal, and passed through n channels. Here we have 1, 2, 3, 4 and n channels. Passed through these n channels, and at the receiver's end we have a demultiplexer. Let us assume the sender is a radio station and receiver is a user. At the receiver end we have a demultiplexer. The responsibility of demultiplexer is to separate the signal. Sorry, at the receiver's end we have a demultiplexer, it will separate the signals. It will separate the demultiplexed signal. See the here. Give me 2 minutes of time. Yeah, this is the frequency division multiplexing. We here in the screen now we are seeing several channels and the frequencies that the channels are using. The frequency level is kilohertz and megahertz. See this diagram will give the clear picture, and this is the frequency level 0 to 1400. This is the frequency level in mentioned in kilohertz. Here see the gap between bands. This is one band and gap is here and gap is here. This band is this band is called as guard band. చిన్న ఎగ్జాంపుల్ చెప్పాలంటే మీకు 98.3 FM ఉంది, 93.5 FM ఉంది, 93.4 ఉండదు, 93.6 ఉండదు. అంటే ఇమీడియట్ గా మనకు నెక్స్ట్ బ్యాండ్ అనేది మనం కన్సిడరేషన్ లోకి తీసుకోము. వై? బికాస్ ఈ రెండు ఇంటర్ఫియర్ అవుతాయి అని చెప్పి ఆ రెండు ఫ్రీక్వెన్సీస్ పక్క పక్కనే ఉంటాయి కాబట్టి దేర్ మైట్ బి ఎ పాసిబిలిటీ ఆఫ్ ఇంటర్ఫియరింగ్ దోస్ టూ ఫ్రీక్వెన్సీస్. That is the reason why we are placing here a guard band. Here you can see the guard band. This guard band will protect from interfering one frequency into another frequency. However, మనకి ఎప్పుడైనా టీవీలో, let us take an example. టీవీలో there is the olden days లో analog communication ఉన్నప్పుడు even now some problems are facing. We are facing some problems. Miscommunication between audio and video. And one channel is interfered with another channel. Oka channel lo audio kanpadutundi, oka channel lo video kanpadutundi. That is all because of this interference. Okay, this guard band will protect from interfering one frequency with another frequency. Okay, see this diagram represents the guard band importance. The next second type of multiplexing technique, that is wavelength division multiplexing. It is said to be wavelength division multiplexing. It is very similar to, as I mentioned before, it is very similar to, see here see the point, last but one point. Wavelength division multiplexing is the form of frequency division multiplexing used for optical fiber. Only in optical fiber communication this wavelength division multiplexing is used. This is very similar to or one kind of frequency division multiplexing. Here mentioned the point. WDM refers to the application of FDM to the optical fiber. Okay, this is very simple scheme. Here we are using a prism. When the light passes through a prism, the colors of the spectrum are spread out. First to see the diagram you can understand. Here see, this is the prism. Here is three different frequencies, lambda 1, lambda 2 and lambda and so on, lambda k. All these are passed through a prism, and the middle one is a optical fiber which carries the beam of light. As I told you yesterday, in optical fiber communication, the small beam of light is passed that carries a small beam of light. Okay, here this light is passed. At the receiver's end we have another prism. This will act as a demultiplexer. At sender, the prism acts as a multiplexer. This will combine these lambda 1, lambda 2 and so on and forms a single light. ఇక్కడ చూడండి అమ్మా, lambda 1, lambda 2, lambda k ఉన్నాయి కదా. ఇక్కడ ఈ మూడింటిని కంబైన్ చేసి ఒక సింగిల్ సిగ్నల్ లాగా, దట్ మీన్స్ సింగిల్ beam of light గా తీసుకొస్తుంది అనమాట. రిసీవర్ దగ్గర ఏముంటుంది మళ్ళీ అనదర్ ప్రిజం. దిస్ ప్రిజం will acts as this prism will acts as a demultiplexer. It will separate again the frequencies. Now move back. Here, if a set of colored light beams, this lambda 1 and lambda 2, lambda 3 are set of colored light beams are each directed into a prism at the correct angle. These three are the three different lights. Okay, three different light beams. Each are directed into a prism at the correct angle. Next, what prism will do? The prism will combine the beams to form a single beam of white light. This white light is passed over the optical fiber. This is the diagram. And the next one is time division multiplexing. This is very, very important. And time division multiplexing and frequency division multiplexing are the most used applications. Most using see, coming to that, in the name itself we have the difference. Frequency division, what happens, what done there, the frequency is divided. In wavelength, the wavelength is divided. The different wavelength beam lights are divided. Now coming to the time division multiplexing, I think my connectivity is a bit slow. I think the voice is not clear. If anyone is facing the problem, just let me know through chat. In time division multiplexing, the time is divided. The name itself says the time is divided. Okay, see here, the time division multiplexing. Here we have in the diagram senders 1 to n. These three users, sender 1, sender 2, sender n. అంటే ఇక్కడ చిన్న సింపుల్ డెఫినేషన్ చెప్పాలంటే ఏంటంటేనమ్మా, సపోజ్ 3 యూజర్స్ ఉన్నారు, 1 2 3 యూజర్స్ ఉన్నారు. వీళ్ళందరికీ మనం ఏంటంటే we will allot a time slot. Okay, whenever a time slot is allotted to a particular user, during that time slot, during that time slot, they can only able to transmit the data. Like Darshan in Tirumala, suppose whenever they allotted a time slot from between 3 to 4, at that time only we need to go to Darshan. Okay, likewise here for each sender, what they will do is they will allot a time slot. Here we are having sender 1, sender 2, and so on, sender n, and these three data is combined. Okay, these three data is combined in a multiplexer, and these three, let us assume these are 1 to 1 to n are 3 users. These all users data is shared, is transmitted over a shared medium. ఎందుకు మనం టైం స్లాట్లో ఇవ్వాలి, ఇండివిజువల్గా ఎవరు పంపించుకోవచ్చు కదా అంటే మీకు డౌట్ రావాల్సింది ఏంటంటే ఇక్కడ why SAR is saying the time is allotted to each user. ఇక్కడ ప్రాబ్లం ఏంటంటేనమ్మా, all we are using a shared medium. షేర్డ్ మీడియంలో ఎలా ఉంటుందంటే మోర్ దాన్ 1 యూజర్, షేర్డ్ మీడియం అన్నా షేర్డ్ ఛానల్ అన్నా ఒకటేనమ్మా. ఒకే ఛానల్ని మల్టిపుల్ యూజర్స్ యూజ్ చేసుకుంటున్నారు. మోర్ దాన్ 1 యూజర్ ట్రై టు ట్రాన్స్మిట్ ద డేటా. వాట్ హ్యాపెన్స్, దేర్ మైట్ బి ఏ కొలిజన్. అంటే సెండర్ A's data will collide with B's data and some others data. That leads to collision, leads to data loss or data damage. Again, the data damage leads to data retransmission. Okay, this all leads to more cost and time defective. Time మళ్ళీ ఎక్కువ టైం వేస్ట్ అయిపోతుంది, మనీ వేస్ట్ అవుతుంది. ఓకే, నెట్వర్క్ రిసోర్సెస్ అన్ని కూడా వేస్ట్ అవుతాయి. ఓకే, ఎందుకు కంబైన్ చేస్తున్నారంటే మల్టీప్లెక్సింగ్ అకార్డింగ్ టు మల్టీప్లెక్సింగ్ ప్రిన్సిపల్. ఈ లెఫ్ట్ సైడ్ ఉన్న మూడు, సెండర్ 1, సెండర్ 2, సెండర్ n అనుకోండి, ముగ్గురు అనుకోండి. ఈ ముగ్గురు డేటాని కంబైన్ చేసి ఎవరు మల్టీప్లెక్సర్ లోకి పంపిస్తారు వీళ్ళు. These are passed data through multiplexer. The multiplexer will combine all these data. మొత్తాన్ని డేటాని కంబైన్ చేసిన తర్వాత ఏం చేసిద్ది చూడండి, ఇక్కడ చూడండి 1, 2, 3, n మధ్యలో చూడండి, డేటా ఫ్లో చూడండి ఒకసారి అందరూ. ఫస్ట్ ఏమో 1 ఉంది, అంటే సెంటర్ 1 కి ఈ పర్టికులర్ టైం స్లాట్ సెంటర్ 1 కి ఇచ్చాడు. తర్వాత సెంటర్ 2, సెంటర్ 3, అంటే డేటా అనేది అంతా కలిసి వెళ్ళినా కానీ మధ్యలో ఏమవుతుంది, ఒక్కొక్కళ్ళకి ఒక్కొక్క టైం స్లాట్ అవుతుంది. హియర్ ద టైమ్ ఈజ్ డివైడెడ్ ఇంటూ స్లాట్స్. మళ్ళీ డిమల్టీప్లెక్సర్ దగ్గర ఏమవుతుంది, సెండర్ 1 దగ్గరికి వెళ్ళాలి పంపిన డేటా, రిసీవర్ 1 దగ్గరికి వెళ్ళాలి. సెండర్ 2 పంపింది రిసీవర్ 2కి వెళ్ళాలి. సెండర్ n పంపింది రిసీవర్ nకి వెళ్ళాలి. అలానే మళ్ళీ సపరేట్ అయిపోతుంది అనమాట. ఓకే, దిస్ ఈజ్ హౌ the time division multiplexing will works. The only thing we need to remember here is the time is divided into slots. The time is divided into slots. For each user, it will allocate a particular time slot. For each user, they will allocate a particular time slot. During the time slot, only they can able to transmit the data. Okay, the other time they are not permitted to transmit the data. The difference here. Is the circuit switching, how the frequency division multiplexing and time division multiplexing is working. This is the frequency division multiplexing. In frequency division multiplexing, the frequency is in the y-axis and the time is in the x-axis. Here we are using 4 users. Let us assume we are just to see the presentation. We are having 4 users: blue, green, orange and violet. Okay, 4 users కి ఏం చేసాం మనం, 4 frequency level సెట్ చేసాం. చూడండి ఒకసారి 4 lines వచ్చినాయి. For 4 users we have allocated 4 lines. Okay, the next point, see the difference here. For blue, one frequency is set. For green, one frequency is set. For orange, one frequency is set, and for violet, and one more frequency is set. Okay, see the next one. This is the time division multiplexing. Similarly, see the difference between the frequency division multiplexing and time division multiplexing. Here the frequency is in y-axis, the time is on the x-axis. See the difference between FDM and TDM. Here, see the vertical ones. Only difference here, the frequency is divided. Here, see the difference. In the above diagram, the frequency is divided. In the below diagram, the time is divided. Just see the difference. Is time division multiplexing, right? In TDM, see, frequency is in the y-axis, time is in the x-axis. See the difference. The time is divided, not the frequency. The time is divided into slots. Each slot is allocated for one user. If requires, more than one slot may be allocated to the users. That is depending upon the algorithms and conditions that they are using. Okay, this is very important point. I'm repeating once again. This is a FDM and TDM example. In FDM, frequency is on the y-axis, time is on the x-axis. How the frequency is divided here? We are having 4 users, above colors. For 4 users, 4 slots are allocated. The 4 frequency divisions are allocated. See the difference. Okay. Similarly, for time division multiplexing, the time is divided. The time is divided for these 4 users. Last, here blue, for user blue, the allocation might be random, the allocation might be ఎలాగైనా allocate చేయొచ్చు అనమాట. అది మనం యూజ్ చేసే టైం డివిజన్ మల్టీప్లెక్సింగ్ అల్గరిథమ్స్ మీద డిపెండ్ అయి ఉంటుంది అనమాట. This is about uh, frequency division multiplexing, wavelength division multiplexing, and time division multiplexing. Now we are moving to frequency division multiplexing and example. Here see, I think this is not in your syllabus. This is, yes. Now moving to the next one, code division multiplexing. Okay, today I will tell you about the introduction about code division multiplexing, and this is very different from frequency division multiplexing and time division multiplexing. In code division multiplexing, this is the technique that we are using in mobile phones. Mobile phone lo manam ee technique use chestam. ఇప్పుడు ఇందాక ఫ్రీక్వెన్సీ డివిజన్ మల్టీప్లెక్సింగ్ జరిగింది. ఫ్రీక్వెన్సీ ఈజ్ డివైడెడ్. ఇక్కడ టైం డివిజన్ ఏం జరిగింది? ద టైమ్ ఈజ్ డివైడెడ్ ఇంటూ స్లాట్స్. ఒక స్లాట్ లో మోర్ దాన్ 1 యూజర్ కనుక, ఒక సేమ్ స్లాట్ లో మోర్ దాన్ 1 యూజర్ డేటా ట్రాన్స్మిట్ చేస్తే ఏమైంది? It leads to collision. ఇక్కడ మన coming to the CDMA, it is the best example for multiple access method. This point you need to remember is the best example. TDM అనేది multiple access method కాదు, FDM అనేది multiple access method కాదు, and WDM అనేది multiple access method కాదు. Only the CDM, code division multiplexing, is the multiple access method. This technology is used in mobile phones. కావాలంటే చూడండి అమ్మా, మొబైల్ ఫోన్స్ అంటే చూడండి, మనందరం all we are using cellular phones. Okay, this is widely used in mobile phone technology. Okay. This the continuation to the CDMA will be explained in tomorrow's class. My connectivity is too low to reach you. Okay. Please make sure everyone should attend the class without fail. Have any doubts during my class, just take the screenshot of that page and send it to me through WhatsApp, and just give me a message. Sir, I have doubt on this topic, and I will get back to you with the phone call, or I'll get back to you message, and whatever the communication that you and me have. Okay, thank you everyone, and have a good day.